We've covered some basic relational operators in this course, and we've even covered the concept of Boolean expressions. Now we're going to take those concepts one step further and talk about advanced relational operators. And the ones that I'm talking about here are the two ampersands together that mean the word and. Then we've got the two, what do you call them, the two pipe symbols or the two vertical bars. They mean the OR operator. So what am I talking about here? And OR. What I mean is if the file is still open and there is still data left to read. Notice the word and there. Or how about if the communications channel is still open or the user is about to enter data on the keyboard. One of those two could mean OR. To give a really basic example, if the age is greater than 80 and less than 90, and less than 90. Also, there is another operator that we can use. It's the exclamation mark operator. This is a special one. It's the unary operator. It's not a binary operator, which means it doesn't sit in between two variables. It sits immediately to the left of a variable, and it means not that variable. You'll see an example of that in the next module. Finally, before I actually show you some code examples, I want to talk to you about precedence. Precedence is, remember I said before that multiplies always happen before additions, and divides always happen before additions and subtractions as well. And that if you want to override those rules, then you need to use brackets. Well, the same thing applies here. There are certain precedence rules, and sometimes they're not exactly what we want. So rather than try and remember every single precedence rule, it's often a good idea to use brackets, just to be on the safe side, until you're absolutely certain that you know what the precedence rules are and when they apply. Anyway, let's go and have a look at some code. This is age6.c. It's actually age4.c, but I've just saved it as age6, and we're about to modify it to introduce some advanced relational operators. Now, if you recall, I went down to this if statement here and I said, this is the condition under which you're a teenager. You're less than or equal to 19 and you're greater than or equal to 13. Notice I used the word and there. Well, if you can make it to this line right here, then you must have made it past this if statement, and you must have made it past this if statement, which means that must be true and that must be true to get there. Notice again I used the word and. Okay, so what if we rewrite that such that we just want to see whether they're a teenager or not? Let's have a look. Firstly, I'll get rid of all this other stuff because we don't need it, all these else clauses. Okay, there's a simplified version. If age is less than or equal to 19, if age is greater than 13, you're a teenager. Okay, let's try and do that as one if statement. This is how you might do it. Replace all of that with double ampersand, meaning and. So, if age is less than or equal to 19 and age is greater than or equal to 13, then you are a teenager. Okay, let me show you a couple of examples of how this is not written. Okay, I've just changed the code slightly. I'm going to delete this in a moment, but I've added a couple of lines that are not correct. These will not compile in C. They won't compile at all. They are clearly wrong. They're not the way we do things. But I want to show them to you anyway because they're very common mistakes. You might read this one. If you're reading it in English, you'd say, if age is less than or equal to 19 and greater than or equal to 13. I'm sorry, it doesn't work that way. You actually have to have the word age in there as well. That's what was missing. Okay, so that's that line. And this one, possibly even more what people might want to do, they might say, if age is between 19 and 13 inclusive. Now, wouldn't that be nice if you could do that? But sadly, you can't. That's just a limitation of C. You can't do it. You have to explicitly specify two operands around each operator, both times. There, and there. So those lines of code are incorrect, and I will now put the code back the way it's supposed to be. Okay, that's better. So, moving right along. That is an example of the AND condition. I'll give you an example of the OR condition. If age equals 10 or age equals 20, then printf blah 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 blah. You can also extend that. You could say or age equals 30 or age is less, or how about is greater than 100. Those are all options. That's a valid, perfectly valid option. Now I've just added a printf line. I'm going to actually save this as age6.c. And before I go on, notice that it is actually possible to put ampersands there as well. There's nothing to say that you have to have all your ampersands on one line and all the ORs on another line. You can mix them up. You can, but make sure that it makes sense. It will still compile, it will still run, but it may not work. Because here, it just doesn't make sense to say this. If age equals 10, or age equals 20, or age equals 30. Once we've got that far, once we've evaluated those three conditions, age, we know that age must be either 10, 20, or 30. So now we say, if age is 10, 20, or 30, and age is greater than 100, well, that can't possibly be true. It's always going to be false. So that statement, the way I've written it, that whole thing is always false. Always, always, always. It doesn't matter what age is, that could never possibly be true. So you might want to keep those things in mind when you're writing your C code. Okay, let's give another example here. If structcomp Bruce is not equal to 0, so your name is not Bruce, and your age is not equal to 40, then you're not called Bruce, and so on. So that's a possibility there. They don't have to be just talking about the same variable. We can have the name variable being compared here and the age variable being compared here, and we can compare them all on the same line. That's perfectly okay as well. So those are some good, reasonably straightforward examples surrounding and or. Now let's have a look at not. Let's have a look at not. Remember the exclamation mark. Okay, let's go back up to our teenager example. We want to say you are not a teenager. We want this to be a valid piece of code. Now clearly that's not right at the moment, because it'll be the opposite. So we can change that, and here's what we can do. We can put a great big not in there. Not age is less than or equal to 19 and age is greater than or equal to 13. Not any of that. If we put the exclamation mark in there, then theoretically that will be true, except we've forgotten our precedence rules, because the way this reads at the moment, all we're saying is not age is less than or equal to 19. What is not age? What is that expression evaluate to? Because we're comparing that with 19. So what is not age? See, what we really need to do here for the precedence is we need to put a brackets there, oops, and we need to put brackets there, so that we are actually applying the not to all of that. So we're saying all that stuff inside the brackets means that you're a teenager. If you put a not outside it, then you're not a teenager. But what if you don't do that? What if you just put the not right there next to the word age? Well, then you're basically saying not age is less than or equal to 19 and age is greater than or equal to 13. Now, that might make sense. It might be a valid thing to do, but I'm guessing not. What does that mean, not age? Okay, well, let's think about it. Age is currently some number. Let's say, I don't know, 15 or 50. What's not age? So what's not 15? Is it possible to say that something is not 15 or not 50? Well, I want you to cast your mind back to Boolean expressions. And I said that if something was 0, then it was false. And if something was non-zero, then it can be thought of as being true. And not, the not operator, makes everything that's true false, and it makes everything that's false true. So, if something is 50, then sure, it's 50, but you can think of it another way as saying, well, it's true, because it's non-zero. You following this? It's not really that straightforward. Anything that's non-zero is true, and 50 is non-zero, therefore 50 is true. So not 50 means false, it's 0. Anything that's false is 0. So if age is a positive number or a negative number, but it's, in other words, it's a non-zero number, some reasonable meaningful age, then not age is going to be 0. Always, always, always. And if age just happened to be 0, if the user entered 0 through the scanf, then it would convert it to 1. Not 50 or 15 or any other number. It would just say, well, I've got to think of some number that's not 0, may as well just use 1. So not age, in this case, is more than likely just going to be 0. So, and indeed 0 is going to be less than or equal to 19. Anyway, none of that is what we want. What we actually want is the brackets like that. Now that will work. That will work perfectly. However, you might think, well, there's a better way of doing it. How could you rewrite this such that you didn't need to worry about this silly not operator? Well, I'll leave that code there and I'll just duplicate it down here. Okay, I'm going to rewrite this code now such that it's exactly the same logic but without the use of the not. I'm going to take that not away and I'm going to reverse this. So if it's greater than 19, I'm going to reverse this one as well. If it's less than 13, notice that the opposite of greater than or equal to is less than. Not less than or equal to, but less than. Because we don't want to include the case of 13. We want to make sure they're not a teenager. So the age can't be less than or equal to 13, because if it was equal to 13, they would be a teenager. So we're almost there. Let's see what this reads so far. If age is greater than 19 and less than 13. Well, there's no age in the world that could be both greater than 19 and less than 13. That couldn't possibly be the case. So we've actually got to change this and here to an or. So let's see if that reads properly. If age is greater than 19 or less than 13, then you're not a teenager. That sounds right to me. So compare those two lines. Compare this line with the not and this line without the not, and you'll find that they are logically exactly the same code. They're just written slightly differently. I'll leave those both in this piece of source for you to compare later on at your leisure. Now, down here with the Bruce example, we could not this as well. We could say not, and then oops. There we go. I've just done exactly the same thing. I've put a not around the whole thing, and now I'll show you how that could be rewritten without the not as well. Okay, now I'll take the not out and change this to an equals, and change this to an equals, and change that to an or. So you might see a pattern here. The way to not something, the way to make, if something was true to make it false and false to make it true, is reverse all the relational operators, so not equals becomes equals, and less than or equal to becomes greater than, and so on, and reverse the ands and make them ors, or reverse the ors and make them ands. It works, believe it or not. This will work here. Well, let's make the printf reflect what's going on. So we're saying stricump is not 0, which means your name is not Bruce. Now I'm making that not, so you are not Bruce. Does that make sense? It sounds a bit funny, but you are not Bruce. That means you are Bruce. And here your age is not 40. So we're trying to find someone who is not called Bruce and not 40. I know it's weird, isn't it? But if you check it out, you'll find that it does actually work. Those two lines are the same. So you might be thinking to yourself, well, hang on, this is really weird. Every time you've used the word not, you've found a case where you can not use the not. Oh, don't we hate this kind of grammar? We can not use not. Yes, and that's true so far. All of these examples where I've used not, we can rewrite them simply, well, much more simply without using not. But let's use the example from our previous piece of code. Remember the old Boolean variable called very old, and here we're going to use very old again. Very old is when age is greater than 80. Okay, and we remember we put the code if very old, then printf, printf you are very old. Okay, printf you are very old, very nice. If you're very old, print you are very old, fine. Now, let's say we don't want to print you are very old. Let's say we want to print you are not very old. Now how do we rewrite this line such that we say you are not very old? We could obviously rewrite this and just simply say this is less than or equal to, but then we'd have to change the name of the variable and call it not very old as well, and maybe we need that variable for something else. So I'm going to put that back. Age is greater than 80. I'm going to put it back. We may actually need a variable called very old. We may be using it all throughout the code. We're not, but we might. We could conceivably be a very important variable that can't possibly be changed, and so we can't go back and change it here. So the only place we can change it is on this if line. Now, I think you know where this is going. The only way we can change that is to say not very old. If not very old, print you are not very old. Now that is a case where you can't change the actual if statement. You can't reverse it like I did with these lines up here. I can't change the ands to ors and the not equals to equals. I simply have to use the not. That's perfectly legitimate. Also, I just want you to compare that line of code with this line of code. I'm going to duplicate it again. If very old equals 0. Now both of those pieces of code are exactly the same. Logically they are the same. They will do the same thing. But I don't like the second one. I hope you're not getting confused here, because in the last module I showed you a code example like that and I suggested that I didn't like the first one. Well, it was similar to that. But I don't like the second one here, because it's comparing very old with 0. I mean, it's perfectly logical and it does work. Because if very old equals 0, that means that this is false, which means that age is less than or equal to 80, which means I'm not very old. So it's correct. It's correct code. But as I read this line of code here, if I don't know what very old is, if I just have to guess from reading the code, then I would assume that very old is an integer. And it's an integer that I'm comparing now with 0. I mean, yes, of course it is an integer, and I am comparing it with 0, but what I'm not thinking of is I'm not thinking it's a Boolean. Whereas this line of code up here, it looks like a Boolean right from the beginning. If I'm saying not something, not very old, it's immediately obvious that very old is some kind of Boolean, because I'm notting it. It's perfectly okay to not integers, and it's perfectly okay to compare Booleans with 0, but I don't like to do that, because it's misleading. The person reading the code will have to take an extra few seconds to try and figure out what you're doing. That is more obvious. This line here is more obvious. That's why I prefer that particular syntax when we're talking about Booleans. Okay, I'm going to tidy this piece of code up and save it as age6.c, and that is our discussion on advanced relational operators. We've seen the use of AND, we've seen the use of OR, we've seen them mixed together, we've seen NOT, and we've seen how NOT affects AND and OR. We've seen where we need brackets and where we don't, although there will be other examples of when we need brackets. So that's the module. Let's move on.